We're looking at measures of spread. Can anyone tell me what a measure of spread might mean? Or has anyone else written them up? Michael? Range. Has anyone heard of interquartile range? Okay, so today we're looking at range and interquartile range. And we're also, from interquartile range, going to look at box and whisker plots. Alright? So, range is a measure of spread. We're looking at where the data goes from and to. So how do we find the range? David? Good, okay, so range is a number. It's not just the highest and the lowest number, it's the mixture of the two, okay? So we take our maximum number, range equals your maximum number. Can you write this down, please? Take your minimum number, and that equals your range. Range is pretty easy. So we can look at a set of numbers like 1, 3, 6 and 12. What would our range be? 11. Why is it 11? 12. Take 1. So our range equals 11. And that's our answer. So range is simple. The only thing you can get wrong in a test is if you put both numbers. If you say range is 1 to 12 or something like that, that's not right. The range is a specific number. It's the difference between those numbers. Any questions about range? Why do you think range might not always be the best measure of spread, the best description of a set of data? Julian? Good, doesn't give you the numbers in between. How else do you think it can be sort of changed or make it not really very accurate for the data? Oliver? Yeah, good. If there's an outlier, which means that there's a number which is really, really big compared to the rest of the data, or really, really small, then the range isn't going to be a good measure of spread. For example, if I added on to this example, 2 seconds, if I add on to this example like 203, then the range changes and the range becomes 203 take 1 and our range is 202. That doesn't tell us much about the data. It tells us that there's an outlier, but it doesn't, like if someone just said the range is 202, you would sort of assume that lots of the numbers were all between that data, okay? And instead, it's actually that they're all close together and there's one outlier. So when there's an outlier, the range isn't the best method. So instead, we use the interquartile range. Right? Any questions about range? Alright, so interquartile range. From now on, I'm going to say the IQR, and we're going to write IQR all the time. Once again, the interquartile range is a number. It's not two numbers. It's one number. But this time, it's the difference between the upper quartile which is also called the 75th percentile or Q3. So the difference between the upper quartile and the lower quartile, which is also called the 25th percentile or Q1. Now I'll explain about the Q1 and the Q3 a bit more in a second. But the official sort of definition for interquartile range is Q3 take Q1 equals the interquartile range. So, can someone tell me what 75th percentile means? Or Q3 or upper quartile, what that means? Yep. Good. 3/4 of the data, 75% of the data is below the Q3. What about Q1? 25%. So you sort of looked at it as being like your top mark is up here, your bottom mark is down the bottom. A bit like when we sent you guys out your little box and whisker plots for your marks last year and before that in maths. Okay, then the 25th Q1 means 25% of the people who did a test or the data is between the bottom and Q1. What about the middle here? What would that one be? It's Q2. What's another name for Q2? Do you think? No. It's the median. Okay, so the median is where 50% of the data is below and 50% of the data is above. So it's not the mean, it's the median. It's like a halfway point. Half of the students who did this test are below that point, half of the students who did this test are above that point. What about this one here? Oh, sorry. What about here? Q3. And for this one, we add on another 25%, so it's 75% are below that point. So if you had like a data point up here, you'd be saying, okay, great, I'm in the top 25% of the course. Any questions about that? Okay, how do you think we find Q2? How do you think we find that middle bit? We've already done it, we've had a lesson on it. What's Q2 the same as? The median. Okay, so to find your upper and lower quartiles, to find Q1 and Q3, we first find the median. Okay, and that's going to be like your Q2. So if we use an example, we'll go 2, 4, 6, 8, 11 and 15. This will be our example. We'll have 2 examples. How do we find the median for this data? Michael? Good. Okay, so we found that there's 2 middle numbers, and so we split it down the middle, and so our median is halfway between 6 and 8, which is 6 plus 2, and divided by 2. So our median is 7. That should just be revision. If that's how we find the 50th percentile, how do you think we can find the 25th percentile? So Q1. Yep. It is. So we find the median of the bottom half of the data. So our second step is to find Q1. We find the median of the lower set of data. So 2, 4 and 6. What's the median of 2, 4 and 6? 4. Okay, so it's in the middle. Q1 equals, sorry, that was 7. Q1 equals 4. How do we find the upper, so Q3? To find Q3, we find the median of the upper set of data. So this time we're looking at 8, 11, 15. What's the median of 8, 11 and 15? 11. So Q3 equals 11. So the last step in this, how do we find the interquartile range? Good. Q3, take Q1, equals the interquartile range. So we've got 11, take 4, equals 7. So your IQR equals 7. Any questions? This is pretty simple, especially when you don't have too many numbers, but there's one way which just gets a little bit trickier. So we're just going to do another example with a different set of numbers, because you need to know. So what you need to be aware of is for this set of data, we had an even number of scores, so we had 6 scores, and so our median was in the middle. See how I drew a line down the middle? It's pretty important that you draw that line down the middle because it splits the two halves in half. It splits the first half as being this section and the second half as being this section. And that then we can go Q1, Q3. It changes a little bit when we have an odd number of data, okay? So, can I move this page down? Yeah? Okay, so if we do an example of this set of data, 5, 9, 11, 15, 17, 21, and 23, okay? This one has an odd set of data. Our median is easier to find. What's our median for this one? 15. Now this time, instead of a line down the middle, we're actually using 15. So 15 is our median. 15 doesn't get included in our upper half or our bottom half now. So this is the difference. Last time the numbers were all included. If you've got an odd set of data, our bottom half are these numbers and our top half are these numbers. Can you see the difference? Good. So just quickly just write if an odd set of data, then the median is not included in the upper or lower quartiles. And that's the only bit which is different. Yeah. You should be writing this down. So how do I find Q1? Okay, so I'll tell you what it is. 9. Q3. 21. And so our interquartile range is 21, take 9, 12. And that's our answer. Why do you think interquartile range is sometimes better than range? It's more precise, it goes right into the middle set of data, yeah? Why else? Good, it excludes outliers. An outlier in essence is just 1 or 2 items. So if you're getting into, only 50% of the data, the middle 50% of the data, then you're going to get rid of those outliers. Good answer. Alright, any questions about that? Okay, last bit is box and whisker plots, so it's how we actually plot this stuff. So we won't use any more examples, we'll use the 2 examples we've got. Alright, so box and whisker plots. It's a graph in which we show the minimum, quartile 1, median, quartile 3, and the maximum score on a scale. It's exactly what we used to send home with your marks. Okay, it's just that. So it's the box with the 2 lines on the outside. So, just quickly, you'll have a scale along the bottom here. And your box and whisker plot should have a box with a line in between, a line. In essence, there should be 5 little vertical lines, okay? This line here is the minimum score. This one here is quartile 1, median, quartile 3, maximum. You can have these both vertical or horizontal. So this one's horizontal, vertical can be up and down. So we'll look at example 1. We had 4, set 2, 4, 7, 11, 15. 2, 4, 7, 11, 15. So 2 was our minimum, 4 was our quartile 1, 7 was the median, 11 was quartile 3, and 15 was the maximum. So what does our scale have to go from and to? What do we have to have included in our scale? At least the minimum up to at least the maximum, probably go one or so more. So I'm going to go from 1 to 16. So our scale needs to go from 1 to 16. So go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, let's go 20. Right? Yes? I just put them in. You always want to have a little bit extra, just 1 or 2 around it. So I just went to the nearest sort of even lot of 5. So you'd only have to get to 15. But I always at least add on 1 more at the start of it. So, once you've got your scale, this becomes really easy. We just have to do vertical lines, 5 vertical lines for the 5 bits of information we have. So I'm going to say 2, 4, that's not 2, that's 3, 2, 4, 7, 11, and 15. So you just draw in 5 lines. You don't need to label them because we're supposed to know what this box and whisker plot represents, what each of the numbers represent. All we then have to do is draw a box around the interquartile range. What's the interquartile range again? Good, Q3 to Q1. So we draw a box between Q1 and Q3, and we draw whiskers to the maximum and the minimum. If you actually think about it, this bit here is the IQR, and from the start to the end is the range. So a box and whisker plot both shows you the range and the interquartile range and the median. So a lot of times in a 2CD test, what they'll get you to do is they'll either draw 2 of these and you have to sort of interpret them, or you might have to draw one and compare it, and it will say like which one has the bigger interquartile range. So you need to look at that box. Which one has the bigger range? Which one has the median higher? So they'll ask you to compare them. But that's your whole big box and whisker plot done. So if we just do the last one, this is the last bit of notes. So we had 5, 9, 15, 21, 23. 5, 9, 15, 21, 23. You don't have to rewrite them, guys. It's just that I don't have them up the top of my page, so I need to be able to see it there. So this time, our scale is going to go from 4 to at least 24. I'll start at 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. It is good if you do these scales with a ruler. What do I do now? Plot them, so draw the 5 dots. So 5, 9, 15, 21, 23, and then we draw the lines. So remembering that these two are not to scale, which one has a bigger interquartile range? The second one, okay, so it's 21 take 9, so our interquartile range is 12. For this one it was 11 take 4, so the interquartile range was 7. Okay, so you should be able to, just from the box, be able to look at this and go, which one has a bigger interquartile range, which one has a bigger range? Any questions? All good? Okay, we're done.